Today we will learn about the carbon and its compounds such as hydrocarbons and their nomenclature. Nomenclature means naming of these carbon containing compounds. Here, so let's discuss about the carbon atom. As carbon atom have the atomic number 6. Atomic number means number of protons present in an atom. So number of protons present in an atom of the carbon is 6. So what is atom? I will just try to visualize in the form of orbital diagram so that you can clearly understand the concept of atomic number. So this is the nucleus of the carbon. It contains proton as it has positive charge. As well, it contains neutrons. Neutrons are neutral in nature. Protons having positive charge and neutrons are neutral in nature. So if as an atom is neutral as it contains 6 protons, it also contains 6 neutrons. Here, okay. So if carbon has atomic number 6, we need to write its electronic configuration. Its electronic configuration is 2 and 4. Electronic configuration represents the number of electrons present in the different shells. In the first shell, there are 2 electrons. So there are orbits around the nucleus, which contains electrons revolving around this nucleus. In first shell, there are 2 electrons. So I will represent here 2 dots. This shell is also named as K shell. In the second shell, there are 4 electrons. 1, 2, 3, and 4. This shell is named as L shell. Here, so this is the outermost shell of the carbon atom. The outermost shell is also known as valence shell, and the electrons present in valence shell are known as valence electrons. Valence electrons. So basically, what does valence electrons represents? Valence electrons represent it represents an atom can form a bond. Yeah, but how many bonds it can form? It depends upon the valence electrons. So why do atoms form bond? Yeah, so to attain inert gas configuration, atoms form bond. Yeah, so this is the first question. Why do atoms form bond to attain inert gas configuration? What is inert gas configuration? If an atom having 8 electrons in its valence shell, then it is considered as stable molecule. So to gain the stability, the atoms want to form the bond. So how many bonds a carbon can form? Carbon can form 4 bonds because its valence shell contains 4 electrons and it needs 4 more electrons to complete its octet. 4 plus 4. So it can form 4 bonds. So we can also use the term valency for it. Valency means it is the ability of an atom to form the bonds and how many bonds it can form. For the carbon, that is 4. So no atom has tendency to give 4 electrons and lose its 4 electrons. So that's why carbon form covalent bonds always. In covalent bonds, there is sharing of electrons. If an atom loses its 4 electrons or gain 4 electrons from another atom, it requires large amount of energy. That's why carbon do not form ionic bond. Ionic bonds are those bonds in which there is loss and gain of electron. Carbon also cannot lose its 4 electron. If it will lose its 4 electrons, then it will remain with only 2 electrons and it will complete its duplet. But it is difficult for the atom. If any atom will give 4 electrons to this carbon atom. Okay, if 4 electrons are added, I should use a different marker. If 4 different electrons are added to this carbon atom, this is also not possible because large amount of energies are released and gained in the process of loss and gain of electrons. So this is not possible. So what is the possible thing is only the sharing of electrons. So carbon form the bonds with another atoms by sharing of electron, and when the electrons are shared, that bond is known as covalent bond. Yeah. Okay. So as the carbon has tendency to form bonds with other atoms to rise large molecules. This property is known as catenation. So this is the particular term when the atoms combine with other atoms and form large molecules. Yeah. So carbon has a very unique ability because other atoms have less density to undergo catenation, because the valence electron of carbon is 4 and its valency is 4. That's why carbon, due to its size as well, undergo catenation. Yeah. So this is a whole concept about that how many bonds a carbon can form with other atoms. So it is 4. So look how it forms a bond with other atoms, such as there are 4 valence electrons present in the carbon here. So this is the least dot structure of the carbon atom. I have represented its 4 electrons. The another atom is hydrogen, and the atomic number of hydrogen is 1. So hydrogen has 1 electron in its valence shell. So it needs 1 more electron to complete its duplet, but carbon needs 4 electron to complete its octet. Here, so draw the atoms of hydrogen along with its electron. Okay, so the sign with cross are the electrons of hydrogen and the dotted are the electrons of the carbons. Now, these both will share the electrons. These will also share the electrons. So now count the electrons of carbon and hydrogens. If we count the electrons for carbon and hydrogen, so this is a carbon, it has already 4 electrons in its valence shell and it is also sharing the electrons of hydrogen also. So 1, 2, 3, 4, 5, 6, 7, 8. So now its octet get completed due to sharing of electrons. And if we check the electrons of hydrogen, there is a single bond between carbon and hydrogen, and there is sharing of electrons, that is 1, 2. So here the duplet of hydrogen is also completed. So that's why to complete its duplet and octet, these atoms do combine to each other. Yeah. So this is the simple way to represent the bonding and sharing of electrons. I have just given the example to you so that you can understand the concept of forming bonds and sharing of electrons. Yeah. So this is a simple molecule which contains only 1 carbon atom. So there are large number of molecules which contains large chains of the carbon atoms. Here, such as the another example which contains 2 carbon atoms. Here, there are 4 electrons a carbon having in its valence shell. So I am representing these electrons around the carbon atoms. Yeah. Now there is also bond formation with the hydrogen. Yeah. So hydrogen, hydrogen, hydrogen. There will be hydrogen, hydrogen, and hydrogen. Yeah. Okay. So as there are 4 valence electrons in the carbon atom, and this molecule contains 2 carbon atoms. So there will be a single bond between carbon and carbon also. Yeah. So as carbon can form 4 bonds, the one bond is with carbon and then other 3 bonds will be with the hydrogens. So the bond here is with the hydrogen, 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 and hydrogen. So there is one bond between carbon and carbon, the other 3 bonds between carbon and hydrogen. So it will complete its valency, that is 4. Now check the number of electrons for the carbon, for the first carbon: 1, 2, 3, 4, 5, 6, 7, and 8. So its octet is completed. So same is true for the second carbon. Its octet is also completed. So this is a molecule which contains 2 carbon. In this, carbon is combining with self atom. So this is also the example of catenation. So the carbon containing compounds can contain large number of carbons, such as 5 carbons, 6, 9, 10, 100 carbons also. Here. So the carbon containing compounds are further categorized into 2 different types. One is saturated compounds, another one is unsaturated compound. As the molecule ethane, such as this molecule H, 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 H. In this molecule, there is single bond between carbon and carbon. If there is a single bond between carbon and carbon, then those compounds are known as saturated compounds. Yeah. And for saturated compound, another term is also used, that is known as alkanes. Okay. So the another category is unsaturated compound. Unsaturated compounds are those compounds in which there is a double bond between carbon and carbon. As well, there might be a triple bond between carbon and carbon. Yeah. So those compounds are known as unsaturated compounds. Always remember, the carbon will form 4 bonds. Look at this molecule. In this, the carbon is forming 2 double bonds with the carbon and the other 2 bonds with the hydrogen. So 2 plus 2 is equal to 4. It will always form the 4 bond. First of all, check the number of bonds between carbon and carbon. Then draw the remaining bond with the hydrogen. So this is another method to draw a skeleton for the carbon containing compounds. As in this structure, the carbon-carbon forms 3 bonds. As 3 bonds are formed, and the 1 bond is with the hydrogen. And 3 plus 1 is equal to 4. It also shows the carbon have the valency of 4. Yeah. So this is the combined term used for both the carbon containing compound for double bond and triple bond, that is unsaturated compounds. These are further categorized into 2 parts, double bond and triple bond. For double bond, there is a specific term that is used is alkene, and for the triple bond, the specific term is alkyne. Yeah. Okay. So if we start with the nomenclature like this, as this compound contains, there is a single bond between carbon and carbon, and there are 2 carbon. For 2 carbon, we will use the word root eth. Yeah. And there is single bond between carbon and hydrogen and carbon, then we will use the suffix ane, and the compound is named as ethane. So this ane comes from this alkane because it is representing there is single bond between carbon and carbon. So ane is used to represent the saturated compounds having single bond. Here, the another example is CH, H, double bond between carbon and carbon. There are 2 carbon again. Then for the 2 carbon, the word root is eth. And there is double bond between 2 carbon. As the double bond between carbon, this term used is alkene, and we will use this suffix "ene" to represent the double bond at the end of the compound, that is ethene. If there is a triple bond between carbon and carbon, then for that term is alkyne. And what is the suffix of alkyne? That is "ine", Y-N-E. So ine will be used to represent the triple bond. There are two carbons. For two carbon, word root is eth, and its fix we will use is ethyne. So that's why we categorize it into different groups: alkane, alkene, and alkyne, to represent the bond, whether it is single bond, double bond, and triple bond. For single, alkanes, and the suffix used is ane, and for the double, the name is alkene and the suffix used is ene, and for the triple is ine. So always use this suffix ane, ene, and ine after evaluating the whether it is single bond, double, and triple bond. Yeah. Okay. So there are some example like C2H4, C2H2, C4H8, C5H10, C4H10, C2H6. Clear? So I have represented these molecules here in the open formula form, open chain formula. This is open chain formula in which all the bonds are represented, like bond between carbon and hydrogen and carbon and carbon. This can also be written as count the number of carbon. There are two carbon, it is C2, and count the total number of hydrogen, 1, 2, 3, 4, 5, 6. There are 6 hydrogen in it. So it is C2H6. Okay, same is true for these molecules. There are two carbon, C2, and the total number of hydrogen in this molecule are 4. Then again the formula is C2H4. So when we write the formulas like this, these formulas are known as condensed formula. Okay, and in these molecules there are two carbon and two hydrogen, and the molecular formula is C2H2. So by this we can also represent the carbon containing compounds. So there are different methods to represent say carbon containing compound. One is open chain formula, another is condensed formula. Okay, the spelling of condensed is like this. Yeah. So I have given some compound to you. So you have to choose and find. Basically, you have to evaluate which is alkane, alkene, and alkyne. Yeah. So if you will draw their structure one by one, it will take a lot of time as well. So there are certain formulas to know whether it is alkane, alkene, and alkyne. If the molecule is alkane, then the formula is CnH2n plus 2. So N represents a number of carbon atoms. Just put the value of N, then you will get that alkane. Suppose if the value of N is 1, here I have put here the value of N 1, 2 into 1 plus 2. Then you will get C1H2 plus 2, C1H4. Then the molecular formula you will get is CH4. Similarly, you can also find for when the value of N is 2. Then put the value N is equal to 2, H 2 into 2 plus 2, then C2H4 plus 2, then you will get C2H6. Clear? So this is the formula which represents alkane. So by this you can find out the alkane. And what is for alkene? Formula for the alkene is CnH2n. Put the value of N here 1, H2 into 1. Then, sorry, for alkene there should be minimum, the value of N should be 2. So put here the value 2 into 2. And you will get C2H4. Yeah. See the difference when the molecule is alkane. And you put the value N is equal to 2, then the formula what you get is C2H6. When you are looking for the alkene, the formula you are getting is C2H4. There are two less hydrogen as compared to alkane. So similarly, we can also identify the alkyne by putting the value of N in the formula, and the formula is CnH2n minus 2. And put here the value is 2H2 into 2 minus 2, then it is equal to C2H4 minus 2, C2H2. Yeah. So if I draw its open chain structure, there are two carbon atoms and two hydrogen bond. It means there is a triple bond between carbon and carbon, and each carbon carries one hydrogen. So this also completes the octet of the carbon, and there are four bonds, 1, 2, 3, and 4. Clear? So these are the certain formulas like alkane, alkene, and alkyne. By using these formulas, we can identify whether the molecule is alkane, alkene, and alkyne. So try these formulas. Look at this molecule C2H4. It contains two carbon. If I put it in the second one, like in the form alkene, CnH2n, here, then C2H2 into 2, then it will give C2H4. Then the first structure is alkene. There is the double bond between carbon and carbon, and it is C2H2. We have done this right now. Then the second one is your alkyne, and it is C4H10. When you put this formula in alkane, so you have to put these formulas in all alkane, alkene, and alkyne. Just try for all of these. So when the molecular formula matches, then it represents a particular type of the compound. So put the value of N is equal to 4 in all formulas, C2H(N), CnH2n minus 2. When the value of N is 4, here 2 into 4 plus 2, C4H 8 plus 2, then it is C4H10. When you put the value in this, which represents the formula for alkene, you will get C4H8, and in this case, you will get C4H6. So just check the which formula is matching with C4H10, that is for alkene. So it means there is a single bond between carbon and carbon, and its open chain structure will look like this, C, C, C. There will be single bond between carbon and carbon. Now just put the number of hydrogen to complete its valency. As the carbon can form 4 bonds, this carbon is forming one bond with this carbon. So the remaining 3 bonds with the carbon. And this is your carbon number 2. Carbon number 2 is forming 2 bonds with carbon. So first of all, number these carbon 1, 2, 3, 4. Carbon number 2 is forming single bond with carbon 3 and carbon 1. So there are already 2 single bonds carbon have. But then it will form another 2 bond with the hydrogen atoms. Here, same is true for the carbon number 3. It has one bond with carbon number 2, another bond with carbon number 4. Then again, it will form the 2 bonds with the hydrogen. The carbon number 4. Carbon number 4 forms only single bond with the carbon number 3. So it is forming one bond, then the remaining will be 4 minus 1, as the carbon has valency of 4, the remaining 3 bonds will be carbon. So you can draw the open chain structure of the particular formula by this method. First of all, you need to judge whether it is alkane, alkene, and alkyne by putting these formulas. And after knowing the nature of compound, then draw its skeleton and the number of bond between carbon and carbon. When you are finished with the number of bond between carbon and carbon, then make the remaining bond with the hydrogen atoms. Then by this you will obtain the real structure of the molecule. Here. So moving toward its nomenclature of the compound, when there is one carbon present in the molecule, then the word root used is meth for 2 carbon. it is eth, ETH, eth. And for 3 carbon, it's prop. And for 4, it's but. For 5, it's pent. And for 6, hex. 7, hep. For 8, oct. For 9, non. For 10, dec. So this is the word rules used to represent the naming of the compounds, as everybody has a different name, such as Mary Kate. Clear? So Mary is the word root given to particular person, and Kate is its surname that is also known as suffix. But some guys have a prefix also, such as if he's Mr., Mrs., or Miss. Yeah. Similarly, these compounds are also named like this. One is prefix, then word root, then suffix is used to name the hydrocarbons. Yeah. And the word root depends upon the number of carbon a molecule have. Okay. So how to name compounds? So we will discuss it with examples. So this is your first molecules. Yeah. Okay. The first rule is count the number of carbons. It has 2 carbon, 1, 2. Yeah. Okay. Then check whether it's alkane, alkene, and alkyne. This is your alkane. Yeah. And analyze the functional group. Functional group here is chloro. So what are functional groups? I want to also tell you what are functional groups. There are certain functional groups such as halogens. Halogens contain chloro, bromo, fluoro, and iodo. These are known as functional groups. And the OH is alcohol. This is also a functional group. CHO, it represents aldehyde. This is also a functional group. And this is your carboxylic acid. This is also a functional group. And this is ketone. Yeah. And in ketone, there is a double bond between carbon and oxygen, and carbon is linked to 2 methyl groups. That is called ketone. And what is aldehyde? In aldehyde, there is a single bond between carbon and hydrogen and double bond between carbon and oxygen. And there is one alkyl group. Clear? Alkyl group means there may be CH3, C2H5, any group may be present. So this is the difference between aldehyde and ketone. Ketone have 2 alkyl groups and aldehyde have only 1 alkyl group. Another one is hydrogen. This is your carboxylic acid. Carboxylic acid, the group represents C double bond O O H. R is any alkyl group. That may be methyl, ethyl, pentyl. It depends on the number of the carbon. So you also have to identify the which functional group is present. So functional group tells the identification of the compound as an it may be the prefix or suffix. Clear? The halogens such as chloro, bromo, fluoro, iodo, these are used as prefix. The other functional group, alcohol, aldehyde, carboxylic acid, and ketone, these are used as suffix. Yeah. So this is your first molecule. Yeah. So you have counted 2 carbons. Okay. And the functional group is chloro in this compound. So what you need is to numbering of this compound. You can start the numbering as well from left side and right side. Yeah. If you start the numbering from left side, 1, 2. Yeah. Okay. Then your chlorine is attached to second carbon. When you go from left to right. When you go from right to left. From right to left, the chlorine is attached to first carbon atom. So always remember the number the carbon according to the rule through which the functional group gets lower number. Functional group should be at the first priority. From the numbering given to the functional group should be lowest locant, at lowest locant. So what is the correct way to number these compound? Here, if we go from left to right, this is the wrong way, and the correct way is when we go from right to left, because the chlorine gets here the locant position, that is 1. But in second case, left to right, the chlorine gets locant position 2. So it should be the lowest position here. So the numbering should be from right to left. Okay. So chlorine is the functional group present over here. And for the chlorine, the prefix is chloro. Okay. Then use word root. There are 2 carbon. For 2 carbon, it is eth. And there is single bond between carbon and carbon. Then use the suffix ane. Yeah. As well, you have to mention the position of chlorine also. Chlorine is attached to first carbon. That's why put here 1 chloroethane. Then look at the second example. So in this case also, the functional group is bromine. That is halogen. So numbering starts from this side, right to left. 1, 2. This is your 1 bromoethane. Okay. So the next molecule is it contains 1 carbon. So for 1 carbon, the word root is meth and prefix is chloro, as chloro is functional group chloro. For 1 carbon meth and there is single bond, then it is methane. 1 chloromethane. Okay. Okay. And this is your 1 bromomethane. Yeah. Okay. So look at the another molecules also. Yeah. So I have already told to you, select the longest chain. Clear? Longest chain. The second is give the priority to the functional group and lowest locant number. So start the numbering from this side, from the right hand side. 1, 2, 3. It contains 3 carbon. So here, and the numbering is from right to left. When you do numbering from right to left, the locants are at lowest position. When you do numbering from left to right, like this, 1, 2, 3. Now double bond is situated at second position and the chloro is at third position. Now the locants are 2, 3. But when going from right to left, the locants are 1, 2. So these are the lowest. So this is the correct way. The above one is incorrect way. So its correct name is, okay, the chloro is present at first position, 1 chloro. And the word root is 3. For 3, it's probe. Okay, there is double bond between carbon 1 and 2. So probe 1 in. When you have to specify the position of double triple bond, then you use its position, whether it is at first position, second position, or third position, and then put its fix in. So its name is 1 chloro probe 1 in. Okay. Okay. So if we look at the nomenclature of this compound, okay, then try the numbering from both sides, from left to right. 1, 2, 3, 4. And at what position bromine gets its number? That is 3. When we go from right to left, like this, then the bromine gets number 1, 2, 3, 4. Then it gets the lowest locant position, that is 2. So numbering should be from right to left. Yeah. So as bromine is at the second position, then you will write 2 bromo. And how many carbons are there? There are 4 carbons in this molecule. So for 4, the word root is butane. But here there is single bond between these atoms. For this, you will use the suffix butane. 2 bromo butane. So basically, the naming is like prefix, word root, then suffix. Yeah. Word root is your the number of carbon. Prefix may be your functional group or any substitution. And the suffix is always in, ein. Okay. Let's clear it with more example. This is your IDO. This is also halogen functional group 1, 2, 3. So 1 IDO propane is its name. Prop is for 3 carbon and in represents a single bond. And it's numbering 1, 2, 3, 4. When you do from right to left, this is the correct way. Here, from right to left, the bromine gets lowest locant position, that is 2. So its name is 2-bromo, 4 carbon, bute, and there is single bond, so it is bromobutane. And the another example is 1, 2, 3. 1, 2, 3. If you go from left to right, right to left, then both are same because chlorine gets its second position. Then its name is 2-chloro. Pro for 3 atoms and in 2-chloropropane. And look at this example. So I have told you, you have to select the longest chain. Okay, there are 3 carbons attached to this carbon, which is attached to bromine. So the longest chain is of 2 carbon. 1, 2. Okay. Then how to name these atoms? 1-bromo hyphen 1, 1. Because at first position, 2 methyl groups are attached. Then 1, 1, 2 represents dimethyl. Okay, so this represents substitution. This is your primary prefix. This is your secondary prefix. These all are the prefix because I have already told you prefix may be any functional group or either substitution. So methyl for 1 carbon and I is used as it has CH3. Here. Okay, and the word root is 2 carbon long chain, eth. When there is single bond, then you will use ethane. Its name is 1-bromo, 1,1-dimethyl ethane. Clear? Okay. Another example is 1, 2, 3. The longest chain is of 3 carbon. As I have started the numbering from right hand side because here the bromine gets the locant position 1. So its name is 1-bromo, 1,1-dimethyl 3 carbon prop and there is single bond in. Yeah. So these are the rules. For this 1, 2, fluoro, it is also halogen. 1 fluoro, eth for 2 carbon, N is your suffix. So its open formula is like this. You can also write it in the open formula. Here, okay. So look at this one. So you have to always prior first functional group as compared to double bond and triple bond also. So there are 2 ways here. Start numbering from left side. 1, 2, 3. Okay. You can either start from right hand side. 1, 2, 3. Here, when you go from left to right, double bond get first position and bromine is at third position. Okay. When you go from right to left, like this way, then the bromine gets first position and the double bond gets the second position. So the lowest locant is 1, 2. So this is the right way to go from right to left. Here, okay. So its name is 1-bromo. Word root is 3 carbon pro, and there is double bond between second and third carbon. So 2 in 1-bromo. Sorry, yeah, put O over here. 1-bromo group 2 in. Here you can also write this formula in this open chain. So this is the IUPAC nomenclature rules for the halogens, and all the rules are also true for the other functional groups, and we will cover up this functional group in the next lecture. And for those functional group, we will use suffix to represent their presence. I will let you know the difference in the next lecture. So this is about the nomenclature of halogens. So thank you and like and share my channel. And if you have any question, then pin me in the comment section.